What is sodium hypochlorite, liquid chlorine? Sodium hypochlorite is an unstabilized, unorganic compound that comes in a liquid form. It has a chlorine availability of 10 to 12% and an active strength of 10 to 12%. When used in a 1% solution, it raises the pH to a level between 9 and 14. Sodium hypochlorite, NaOCl, is a liquid solution containing approximately 15% chlorine. It is a liquid chlorine-releasing disinfectant commonly used to treat commercial pools. It is popular due to its convenience of liquid chemical feeding and relatively low cost. When introduced into pool or spa water, it reacts to raise the pH. Sodium hypochlorite, natrium NaOCl, is a liquid chemical with CAS number 7681529 and UN ID number UN1791. It is not flammable and has a low level of stability. It does not contain any stabilizer, and it does not increase the amount of cyanuric acid in 10,000 gallons of water. When introduced into pool or spa water, it reacts to raise the pH. The strength when used at a pool or spa facility is 10 to 12% available chlorine content, ACC. With a pH between 9 and 14, the pH must be corrected by the addition of an acidic material. What is hypochlorite? Hypochlorite refers to any compound containing a metal ion and the O-chlor- anion. It most commonly refers to calcium, sodium, or lithium hypochlorite in pool usage. These compounds are often used as disinfectants in swimming pools due to their ability to effectively kill pathogens and algae. Is sodium hypochlorite and liquid chlorine the same? Yes. Sodium hypochlorite and liquid chlorine are the same. Sodium hypochlorite, NaOCl, is also known as liquid chlorine. It is a liquid solution that contains chlorine and is commonly used to treat commercial pools. How does chlorine is in liquid chlorine? How much chlorine is in liquid chlorine? Liquid chlorine contains 8%, 10% or 12.5% available chlorine. 1 gallon of liquid chlorine, 12%, contains about 1 pound of pure chlorine. What are the physical properties of sodium hypochlorite? Sodium hypochlorite is available in two concentrations, 10% and 12%. The 10% solution weighs 9.5 lbs per gallon and increases TDS by 0.83 lbs per gallon in 10,000 gallons of water. The 12% solution gains 9.74 lbs per gallon and increases TDS by 1 lbs per gallon. Both solutions have a pH of 13 and a shelf life of 60 days. How stable is sodium hypochlorite? Sodium hypochlorite can lose a significant amount of available chlorine in just a few days. Its stability is greatly affected by sunlight, heat, pH, and the presence of heavy metals. The higher the chlorine concentration or temperature, the faster the deterioration. Iron, copper, nickel, or cobalt can catalyze deterioration, with iron being the most problematic. Even a small amount of iron can cause rapid deterioration of sodium hypochlorite solutions. Iron contamination can come from the caustic soda used in manufacturing. If the iron concentration in the solution is only 0.5 ppm, it can rapidly deteriorate in a few days. The most stable sodium hypochlorite solution is 10% with a pH of 11.0 and iron, copper, nickel, and cobalt below 0.5 ppm. It should be stored in a dark room at about 70 degrees Fahrenheit or 20 degrees Celsius. What is the half-life of sodium hypochlorite? The half-life of a substance refers to the time it takes for half of it to degrade. For a 10% sodium hypochlorite solution stored at 77 degrees Fahrenheit, the half-life is 220 days. This means it will degrade to 5% strength in this time. How quickly does liquid chlorine lose its strength? Liquid chlorine degrades rapidly due to its instability according to the Handbook of Chlorination, 4th edition, JOC White, published in 1999. The degradation rate increases with higher chlorine concentrations and temperatures. The presence of metal like iron, copper, nickel, or cobalt also accelerates this process. Iron, even in small amounts, can cause rapid deterioration of sodium hypochlorite, especially if it contaminates the caustic soda used in manufacturing. The most stable sodium hypochlorite solution is 10% with a pH of 11, not 12.5% with a pH of 13. It should be stored in a dark room at 70 degrees Fahrenheit or 20 degrees Celsius. The table below shows the degradation of 10% and 12% sodium hypochlorite solutions over time. What is the liquid chlorine degradation table? The liquid chlorine degradation table is a table that shows the degradation rate of liquid chlorine sodium hypochlorite over time. It provides information on the percentage of available chlorine remaining in 12% and 10% sodium hypochlorite solution at different time intervals. The liquid chlorine degradation table is as follows. 10 days, 12% sodium hypochlorite 11.5, 10% sodium hypochlorite 9.7. 20 days, 12% sodium hypochlorite 11, 10% sodium hypochlorite 9. 30 days, 12% sodium hypochlorite 9.7, 10% sodium hypochlorite 8.7. 40 days, 12% sodium hypochlorite 8.8, 10% sodium hypochlorite 8.5. 60 days, 12% sodium hypochlorite 6.2, 10% sodium hypochlorite 8. 90 days, 12% sodium hypochlorite 4.7, 10% sodium hypochlorite 7.2. How can you test the strength of sodium hypochlorite? There are test kits available for measuring the concentration of sodium hypochlorite. This includes Taylor Technologies Chlorine Bleach, Test K1579, Lamont Company's Chlorine Model LB, Code 7894, Edge Hypochlorite Test Kit Model CN-HRDT. These kits can help ensure the sodium hypochlorite used or cell maintains its strength. Where is sodium hypochlorite used? Sodium hypochlorite is used in commercial pools and spas. It is a popular disinfectant for these facilities due to its convenience of liquid chemical feeding and relatively low cost. When introduced into pool or spa water, it reacts to raise the pH. The strength when used at the pool or spa facility is 10% to 12%. Available chlorine content ACC with a pH between 9 and 14. The pH must be corrected by the addition of an acidic material. It is also used in residential application and some small pools when the facility is close to bathers. Sodium hypochlorite is safe to use in white plaster, color plaster, vinyl liner, fiberglass, acrylic and painted pool. How is sodium hypochlorite used? Sodium hypochlorite is used for regular chlorination and superchlorination. It provides 10 ppm and 12 ppm FAC respectively when 1 gallon is added to 10,000 gallons of water. The amount required to increase FAC by 1 ppm in 10,000 gallons is 12.8 Oz for the 10% solution and 10.6 Oz for the 12% solution. How to increase chlorine in the pool with sodium hypochlorite? To increase chlorine in the pool with sodium hypochlorite, you can use a simple formula to calculate the amount of chlorine needed. First, determine the desired increase in parts per million, ppm of chlorine in the pool. Then, divide the pool's volume in gallons by 10,000. Refer to the chlorine dosage table to find the amount of chlorine needed to increase the chlorine level by 1 ppm. Multiply the values from these steps to get the total amount of chlorine needed. For example, if you have an 18,500 gallon pool and want to raise the chlorine level by 3 ppm using 12.5% sodium hypochlorite, you would need approximately 2 quarts or 1/2 a gallon. Sodium hypochlorite is usually introduced into commercial pools and spas using displacement feeder pumps. Manual addition is common in residential applications, some small pools when the facility is close to bathers. The usual pH correction with muriatic acid involves using between 12 and 16 fluid ounces for every 1 gallon of sodium hypochlorite. Sodium hypochlorite can be applied while pouring or pumping. It initially raises pH due to hydroxide, but when HOCl degrades, it makes HCl, which lowers the pH. The net pH effect is near zero. What happens when sodium hypochlorite is added to water? When sodium hypochlorite is added to water, it produces hypochlorous acid and a byproduct. So natrium OCl plus H2O results in HOCl plus Na plus OH minus. The hypochlorous acid then dissociates into a hydrogen ion and a hypochlorite ion. HOCl results in H plus O chlor minus. When added to water, sodium hypochlorite compounds form hypochlorous acid by releasing the sodium ion and picking up a hydrogen ion. The only difference between the reactions of any hypochlorite and chlorine gas is the side reaction. How does sodium hypochlorite affect TDS? Sodium hypochlorite affects TDS by introducing inert ingredients, including a substantial amount of salt, NaCl, and some amounts of sodium hydroxide into the water. After reacting with contaminants in the water, it leaves a chloride ion Cl and sodium ion Na, which do not evaporate and are only removed when water is removed from the pool. This ion builds up as TDS over time. What are the benefits of sodium hypochlorite? Sodium hypochlorite acts as a primary sanitizer and disinfectant, killing or living microorganisms and disease-causing organisms. It also serves as an oxidizer, destroying ammonia and swimmer waste, and as an algicide, killing algae. It provides a lasting residual effect. How to store sodium hypochlorite? Sodium hypochlorite should be stored in a cool, dark environment. It should also be stored in a vented container due to its gassing off. The container should be kept in a cool, dry, well-ventilated place. The most stable sodium hypochlorite solution is 10% with a pH of 11.0 and iron, copper, nickel and cobalt below 0.5 ppm. It should be stored in a dark room at about 70 degrees Fahrenheit or 20 degrees Celsius. How is sodium hypochlorite sold? Sodium hypochlorite is sold in various concentrations. Pool stores sell sodium hypochlorite, also known as liquid chlorine, in 10% and 12.5% concentration. Grocery stores, home centers and big box retailers typically sell sodium hypochlorite as bleach in 5.25%, 6% and 8% concentrations. Sodium hypochlorite, also known as liquid chlorine, is a liquid solution that contains approximately 15% chlorine. It is available in two concentrations, 10% and 12%. The strength when used at the pool or spa facility is 10% to 12% available chlorine content, ACC. With a pH between 9 and 14, it typically contains 8%, 10% or 12.5% available chlorine and does not include a stabilizer such as cyanuric acid. Although it can be made with a chlorine concentration of up to 15%, this is unstable and will quickly turn into gas. Therefore, it is usually produced with a concentration of around 12.5%, with most manufacturers guaranteeing a minimum of 12%. It is even more stable at 10%, and in some regions 10% sodium hypochlorite is produced and sold.